All right, so now we've got this, we need to say something intelligent. We've calculated the Ferris wheel's centripetal acceleration, right? We get that the acceleration is something like 1.09 meters per second squared, right? And then we've got this data that has the g-force going up and down, right? And what's going on there is that, of course, you're going from the top to the bottom to the top to the bottom, right? So in general, at the top, you're going to have 1g minus the ride. And at the bottom, it's going to be 1g plus the ride. Okay? So this is actually when you're at the bottom, okay? When there's more g-force. And this is when you're actually at the top for the Ferris wheel anyway, right? When you have less g-force, right? So sort of running through the middle of this is 9.81. And this should be 9.81 plus 1.09. So we expect to see, let's see, plus 9.81. We expect those maximum g-forces to be about 10.9. And then the minimum here should be 9.81 minus the 1.09. So 9.81 minus that guy should be about 8.72. Okay, so now we got to look at our data and see if that is indeed what's going on, right? Okay, so let's take a look at the data. You know, this is where we need to, lie a little bit if it, got to cover our tracks, right? So notice that this, if you look at these data points here, we predicted that it'd be about 10.9, and sure enough, this is when we're at the bottom, and it does seem to be 10.9, although it does bubble around quite a bit, right? Okay, so one of these little regimes, it would be kind of cool to actually find it. What is this, about 18 seconds or something like that, right? To find one of those and see what that actual average is, okay? But anyway, you can see that these g-forces here, that's about 10.8, 10.9, okay? And then we predicted it would be about 8.7 for these guys, and sure enough, right, there's about 8.7. You can bubble that around like that. So you can see that our prediction is actually pretty good, and that's because physics works. Okay, I don't know what to say. Okay, but that's the kind of comparison that you have, right? So you should be looking at this and going, oh yeah, that's about 8.7 or something like that, right? And I suppose we could add grid lines or something like that to this to help us, right? That might be helpful. Let's do that. Let's add some grid lines. Edit the chart. Let's customize it. Grid lines and ticks. Major spacing type. Step value. Let's make it step by 1. And let's do step by, how about 0.2? I'm afraid to do 0.1 because it'll, ooh, look at that. That's pretty cool. So now you can see, and really we just need these, right? So you can see that really it's, the g-force is, that's about 8.6 there. So the low Earth number is a little bit off, right? And you can see that 10.9, I mean, you can pick any point you want. There's so much noise in there, right? Okay, but definitely this prediction that we had, right, of 8.7 and 10.9 seems to be correct, okay? Now, if you chose to get the data without G, I honestly, nobody's done it, okay? I'm a little suspicious about the data without G. But, maybe it works. I don't know. I'm suspicious because it has to be done by software. I'm just going to stop talking.